Okay, hello guys. Today we'll be discussing whatever we saw in the NCRT group that we created. So first we have this ethanol water mixture, which causes what do you say, minimum boiling point azeotrope and 95% by volume of ethanol. And the solutions that show large negative deviation is nitric acid and water, and we take 68% nitric acid and 32% water by mass with a boiling point of 393, which I will not be remembering. Then Felling test and Benedict test. Yeah, so what do you say? Black copper 2 oxide is formed on heating a suspension of copper hydroxide in alkaline solution. Okay, if there's alkaline solution, black copper oxide from copper hydroxide is prepared. Okay, if there is a reducing agent present in the reaction medium, then orange red copper oxide is prepared. Okay, so basically reducing sugars, they only contain aldehyde group or alpha hydroxyketone, and that's why they can reduce CO2 plus ions in alkaline medium. And yeah, to that's all. So this formula is very necessary because it's directly asked E power ax by a square plus b square into a sin bx minus b cos bx. Okay, and in this thing, carcinogenicity and toxicity, yeah, they're caused because of what do you say? If you take two benzene rings and we fuse them together, uh, like on two sides, and they are said to be toxic and cancer producing. This can be for polynuclear hydrocarbons also. They just have to contain two benzene rings joined together, and yeah, they are formed by incomplete combustion of organic materials like tobacco, coal, petroleum, and they enter into human body and finally damage DNA and cause cancer. And obviously I will not be remembering all of these structures, but as you can see, the common thing in them is that two benzene rings are joined side by side. Okay, and then I'll be skipping that one because I'm not sure about the answer, but I know the answer is D, but I don't know the logic. Basically, hydrazine contains nitrogen but does not give um, blue color because in lasagna test, it does not give blue color. I think mainly it is because hydrazine is NH4, sorry, NH2, NH2, right? And it does not contain carbon, so it can't create that CN stuff. But I'm not sure. Correct me if you're watching this video. And then you have pyrolysis or cracking. Cracking, basically, we take one any hydrocarbon and you apply these catalysts, okay, zeolite Al2O3, and it will form a bunch of various all the variations of this organic compound with less than the hydrogens that are present and less carbons that are present. So as you see, there is this, which is the same thing is also formed, and here two hydrogens have been gone, so that's why there is one double bond. So same way for this compound, this compound, this compound, they're all formed by pyrolysis. They're used to break down larger hydrocarbons, smaller ones. Okay, so then you have FeCO9 structure. So FeCO9 structure is very similar to CO29. It is Fe2CO9, and CO2CO9 is also something similar. It's like this. Basically, you can remember it if you remember CO29 structure, right? It's the same thing, but like it's the same thing as that, right? It's like, imagine this was CO and this was not there. That is CO2 CO9, or I think it's CO9. Okay, so then you have something like that. Basically, um there's no one extra of this. Okay, and yeah, so as you can see from this picture, Mahi has sent that CO, for some reason, CO C2043 is diamagnetic, even though C oxalate is a very weak ligand. Okay, then you have CRO5 butterfly structure, which is blue color. Also, amyl alcohol turns blue color in this, and it is Cr6 plus. And then you have bromine octoxide, which you have to mug up the N factor, or you could say oxidation state, and we have to mug up the structures, which is Br and double bond O, double bond O, double bond O, and you keep spamming that. And then you have one note of sent by Aniket, which is Ziegler catalyst is V2O5, Wacker process is PDCl2, polymerization of alkynes is by Ni2 plus, decon process is CuCl2, and Ziegler Natta catalyst is TiCl4. Okay, then Yeah, this tolerant reagent is very important. The tolerant reagent reaction, they have asked many, many times, many countless times. As you can see, it releases 3NH2. And yep, I mean, you will have to mug up the stoichiometry of this actually. So please pause the video here and make sure you mug it up right now. RCHO with 2 Cu2 plus and 5 OH gives RCO minus with, what is this, red precipitate and 3H2. Okay, so now this is also a very important paragraph. I'll be reading it line by line. The OH group attached directly on the ring of an aromatic compound is called phenolic OH group. Phenols are weakly acidic, therefore they are not soluble. They are soluble in NaOH solution, but at the same time they are not sufficiently acidic to be soluble in sodium hydrogen carbonate, meaning NaHCO3 solution. As we know that forms H2CO3, so obviously. So then phenols gives colored complex with neutral ferric chloride solution. For example, phenol gives a complex of violet color. As you guys can see, it's violet color. Please remember that. And this is the complex FeC6H5O. And obviously, C6H5O minus is there. And there's six of those bounded to one Fe. And that is not something that I knew. So please make sure to mark it up. There's six phenol rings coming towards Fe like there is no tomorrow. So yeah, then resorcinol, ortho, meta and para cresol. Cresol का structure तो पता है. It will be like this, I think. Uh, ortho cresol pass like that, right? So wait 1 second, is that? Oh right, sorry guys. Actually, cresol structure is this. My bad. I was remembering it wrong, so I just checked it. So yeah, cresol structure is that, and ortho para means you're just switching away the CH3 group, right? So now resorcinol is the one with the double OH, so don't worry about that. And as you guys see, resorcinol also gives yellow, I mean violet, and these three gives blue coloration, and catechol gives green color. Okay, so catechol gives green color, which is very important. I don't think it has come in a PYQ yet, so it can come in RES, which rapidly darkens. It will become dark green. And 1 and 2 naphthol do not give characteristic colors. That also I did not know, so please go through it. Phenols conduct with phthalic acid anhydride in presence of concentrated H2SO4, which is just phthalate test. So phenol condenses to give phenolphthalein. Phenolphthalein, okay, which gives dark pink color with NaOH. This is called thalendite. Thalendite is preparation of phenolphthalein. It's given in Akash sir note. Oh yeah, by the way, the structure for catechol and resorcinol. This is catechol, and resorcinol is the meta version. That's all. So it's like, you could say it's like this. So yeah, this one will give what do you say, the violet coloration, and catechol gives the green coloration, which, so cat, right, catechol cat, so that's why green color like that. I'll remember. I don't know how you will. Articles can be electroplated with silver and gold much more smoothly than evenly with the formation of these two complexes, okay, Ag and AuCN2. And obviously there'll be CN2 because Ag complexes with two oxidation state, a very with two coordination number are very common. Like for example, you have atoll and reagent also, AgNH3 twice. Okay. In black and white photography, the developed film is fixed by washing with hypo solution, which dissolve the undecomposed AgBr to form a what is it, silver thiosulfate complex. It is very important. I'm telling you, it will come in JEE Mains 2026. Then you have chelate therapy. Yeah, so chelate therapy is basically removing toxic proportional plant and animal systems, and excess of copper and iron are removed by D-pencilamine and D-ferrioxam. As you see, ferri means iron, so you can easily recognize that. Copper is pencil. I don't know how the hell you'll recognize that, but please just mug it up. And EDTA is used for the treatment of lead poisoning. As you can go, like as we talk about it. And also I think there are more in coordination compound, so when you're going through it, please read it, because I'm pretty sure Na2EDTA Na2EDTA is used for detecting is used as a titrant to detect for hardness of water, and hardness of water is caused by Ca2 plus and Mg2 plus. It's also mentioned in this, and EDTA structure and all are given, so please just go through that. Also cisplatin is used to inhibit the growth of tumors. Okay, now this one is very basic. This is just what do you say, the graph of anomalous behavior of water. And obviously we can see through the graph that the volume is decreasing till 4 degrees Celsius, then from 4 say it's shooting up. Okay, then after that you have this very important line, because this is come in ncrt exemplar, and it has also been in a pyq. So basically solution is blue. Okay, initially it is blue at room temperature, but when you place in a freezing mixture, when you reduce the temperature, it goes back to becoming pink. That's all. So you got to mug up these compounds also. And also obviously the hybridization is changing. I think this is tetrahedral. I will check it on it, and or you guys let me know in the comments. Then after that we have, oh, that's it. Okay, yeah. Then you could say that we have more screenshots. And molybdenum oxide, as you guys can see, molybdenum oxide is used for oxidizing alkanes to aldehyde, as I've written in this reaction over here very clearly. And then you have mesityle oxide. Mesityle oxide is just the self aldol product of this ketone. Okay, just check it if you want. It is a self aldol product, and when you supply heat, it'll eliminate and form this double bond here as well. Then you have intolerant for aldehyde, overall number of electrons transferred through tolerant reagent formula. This per aldehyde to form silver mirror is 3. I'm pretty sure, you guys can check it once. I'm not actually fully sure. And then you have which of the following options is correct regarding the property of benzene diazonium fluoroborate. As it's written in ncrt, it's written under amines chapter and under diazonium salt physical properties. Okay, it's written that it is water insoluble and stable at room temperature. Okay, yeah. Then diazotization reaction of aniline with NaNH2 and HCl. Excess of HCl is used to suppress the concentration of free aniline available for coupling. Okay, so yeah, that makes sense. I mean, obviously you would want to not have it couple all the time, because you want to do other reactions with diazotization, right? Diazotization is formation of N2Cl. So then this is a Q of T question. Basically, first you acetylate it so that it can be free to electrophilic aromatic substitution, and then you put H2SO4 in a para position. After that, you have HNO3, which does which is blocked actually in the para position. It's blocked by SO3H, and when steam distillated, this SO3H cuts this bullshit. What do you say? The AC2O cuts, and you get option B. That's all. Then this one. So I'm not sure if this formula is going to be useful ever, but a bar of length L, breadth B, depth D, when loaded by a center of a load W, sags by an amount given by WL cube divided by 4B D cube Y, and Y is Young's modulus, as you guys know that, and W तो weight है, तो yeah, that's all. Oxidation of aniline with manganese dioxide and sulfuric acid, it produces parabenzoquinone, because manganese dioxide is a strong oxidizing agent. So yeah, I mean, sorry, keep drawing it wrong, but benzoquinone is something like this actually. So yeah, one second. Yeah, parabenzoquinone is that itself. Then you have which of the following amines can be oxidized to the corresponding nitro compound with potassium permanganate. And this is, I don't know if it's fact based, Purav has sent it, and it's option number D. Okay, which of the statement is not true? Yeah, I mean, this one is kind of obvious, but then actually option C is the one you have to be looking at. Nitrogen gas is evolved when ethylamine is treated with nitrous acid. As we guys know it, that it undergoes the diazonium reaction, NH2 plus, N2 plus and Cl minus, and that when you treat it with water or any like dilute acid or some, I mean, when you pass water to it or something, basically the N2Cl part, N2 will cut, and it'll just form N2 gas. So yeah, that is true. So they're asking it's not true. So obviously it has to be B. And over here you got to learn that 2 degrees salt, 2 degrees amines form N nitroso salts like this, N nitroso amines like this. Okay, N nitrosamines, and one obviously the normal ones form diazonium salts. Next we have Zn and NH4Cl. They form NH. It reduces. It is a reduction. Yeah, it's a reduction. So it reduces NO2 to NHOH, and that is something that we have to mug up. Okay, please just mug it up. Okay, same question has come over here. And the answer is phenyl hydroxylamine, I'm pretty sure. Yeah, so let's move on. So that is a useless screenshot, sorry. Um, yeah, so basically in this question, um, yeah, so we can use SnHCl, FeHCl, ZnHCl, H2PD, and H2N rainy nickel. So I think the answer is 5, but I don't know. I'll ask Akash sir and let you guys know. This one can be logicked out pretty much, but basically in an acidic medium, like we remember that in an acidic medium the diazotization happens with n itself, right? Meaning like that, um like how do I explain this, like this diazonium forms salt forms. Same thing happens here. The n double bond n group is attracted to, what do you say, the NH2 wala group, so it's formed right beside the NH2 one. Same thing you can say for basic medium, OH minus, and as you can see that basic medium pay, this will become O minus, which will cause better EAS actually. So yeah, so just remember that. And then this is, sorry, a useless screenshot, and you can, I don't know if this is in syllabus, I will be skipping it. Okay, fuel cells. So, in a given cell, hydrogen and oxygen are bubbled through porous carbon electrodes. Okay, carbon electrodes into concentrated aqueous sodium hydroxide. And catalysts like finely divided platinum and palladium are incorporated in the electrodes for increasing the rate of electrode reactions. So, our correct answer will be option C. Please mug it up. Then you have, so yeah, and yeah, this is known as 1:1, 2:1, and 2:2, 2 - 2 types electrodes on respectively. Because I think my logic is that it forms Na plus Cl minus same way. So yeah, and then you have next electromeric effect. This is a temporary effect only when a certain type of thing is near something that is going to attack. It's written in NCRT. Please go through it. It's there in GOC chapter, and yeah, it's just formation of the, like, it's a temporary effect. That's all you have to mug. So yeah, this assertion reasoning question. The ionization of hydrogen sulfide in water is low in the presence of hydrochloric acid. Hydrogen sulfide is a weak acid. Yeah, both are correct, okay, but then reason is not the correct explanation for assertion. And that is because of common ion effect caused by hydrochloric acid. The H plus released by hydrochloric acid would be much more dominant than hydrogen sulfide. And yeah, so you have these couple of reactions given by Puram, and it's asking where is delta Hx is equal to delta Hf. Yeah, so as you guys know that we have to check where they are at standard state. So as we know that O3 is not the most stable allotropy of oxygen, and CO is not, like, it has some delta formation, but here in this reaction all of them are in standard state. Like the they're already like they are existing like that in nature, meaning that doesn't require any external delta H to form them. So yeah, so B is our answer for this one. Actinoid contraction is greater than element to element from lanthanoid contraction, that so we know. So I wanted to highlight that the battery industry also requires Zn and slash NiCod. Okay, and TiO and MnO2. TiO is used for pigment industry, and MnO2 is used for dry battery cells. Mark that up right now, or else I will kill you. Um, Enthalpy of formation of most stable allotrope is taken as zero. Same concept we have used in this question, and they can ask anything in mains. I'll be skipping this question. Next question. Um, the on heating with KHSO4, oils and fats give characteristic odor of acrolein. This is the test for glycerol present either free or combined as an ester. So acrolein is formed, as you guys can see. Yeah, so mug up the structure as well because they've asked it in, what do you say, the QFT. Next thing is An exothermic process, which is non-spontaneous high temperature, may become spontaneous at low temperature. Spontaneous process is an irreversible process and may be reversed by some external agency. Yeah, so as you guys can see that the reason and assertion are correct, but they don't explain each other because they're saying external agency. And I mean, it kind of does, but it's fine. Just mug it up what to do at this point. So yeah, this one is just what do you say? The 231 exception given in NCRT. Read all the theory pertaining to that because they've explained it in a decent way for once. Oh my god. Yeah. So yeah, from here. So yeah. So as you guys can see that linkage isomerism. Okay. In linkage isomerism, this is coming. So CONH35NO2Cl2 is obtained in the red form, and when it's bound with when it's bound with N, okay, and in the and it's formed in the yellow form when there is O, when it's bound with O, okay. Wait, I got it mixed up. Sorry. So they're saying that um the red form is obtained when the nitrite ligand is bound through ONO, and yellow form is when it's bound with N. As we know that like N containing salts are like yellow kind of, so we can just say like use that kind of logic. So then you have these four like pairs, right? So as you have zero um ENs. If you have zero ENs, it became green. If you add one EN, it becomes light blue. If you add one more EN, it becomes dark blue. And if you add all three ENs, it will become a pink, purple type or violet, you could say, color. And valence bond theory, we can read through. I mean, I'm not going to explain all these points because they are kind of common sense, but make sure you're learning all of this. Pause the video here and learn. Yeah, so this is one thing that everybody skips at estimation of carbon monoxide, right? So we know how to estimate oxygen, right? Oxygen when you react, sorry, you'll get oxygen, right? So from there you react C plus O2 to give CO at very very high temperatures. This is coke, right? Hot coke. Hot coke reacts to form CO. CO, yeah, so CO reacts with the given I2O5, with the given I2O5 and forms CO2, okay, and I2. And both of them can be tested CO2 to test, you know, right? And I2 can be tested with starch solution. And they've given that in NCRT, so please make sure you mark it up. And this also is given estimation of carbon monoxide. Even though in this test you're estimating what? Oxygen, O2. I mean, that you obviously will do by estimation of carbon monoxide only, but yeah. So I think the takeaway from this one is that ionization enthalpy, energy, and electron affinity are defined at absolute zero, and this kind of stuff will come in assertion reasoning or like maybe an MCQ, but you just gotta mark this up like it's also valid for ionization energy only. So yeah, all of these two are right. And electron gain enthalpy, you just make everything negative. If you see this is negative, this is negative, CP becomes delta, CP becomes negative, like damn. So yeah, basically that's just CP, right? And then you have bond angle of ozone. Bond angle of ozone is 117. Don't hesitate to mark it up because they have asked bond angle of NR3 before, which is exactly 108 degrees as prescribed by NCRT. Then you have a P block thing. Reducing property of dioxide decreases from SO2 to SO2 to TeO2. And SO2 is reducing while TeO2 is an oxidizing agent. Basically, so the series is O Sanchit Sexy Teri Potti Lauda, right? Um, so as you guys can see, SO2. SO2 is all the way up and TO2 is all the way down. So yeah, that's all. Then enthalpies for different types of reactions. This is the definition of enthalpy. I'll be reading it out because I don't give a shit. Standard enthalpy of combustion is defined as the enthalpy change per mole or unit amount of a substance when it undergoes combustion and all the reactants and products being in the standard state at a specified temperature. Okay, this is the reaction of SiCl4 with H2O. I'm not sure if this is important, but we can just easily remember it. Just the water gets added in terms of OH, and if you put more and more and more and more in an acidic medium, it'll form silicic acid. So this give reasoning one is also there. White fumes appear around the bottle of anhydrous aluminum chloride. Give reason because it gets hydrolyzed with atmospheric moisture to liberate HCl gas, and HCl gas, moist HCl gas especially, color is white. Okay. Then you have behavior of BCl3 as a Lewis acid, and I mean generally it decreases with increase in size down the group. That makes sense, right? And then you have BCl3 which accepts a lone pair to form this adduct. Okay, there's an adduct thingy, so it has been asked in neve before, first few tests it has been asked, and yeah, and done. So SN in plus 2 state is a reducing agent. Okay, so SN has as what do you say? SN has dog shit inert pair effect. Okay, as said by Mahi, as quoted, and lead compounds in plus 2 state are stable, but in plus 4 state are strong oxidizing agents. So as you see, as you can see, SN2 plus is a reducing agent. Okay, but what do you say? PB4 plus is an oxidizing agent. Look at the duality of nature over there. And then next you have, this was kind of repeated, but I'm just going to be summarizing this part. Felling's test. Felling solution A is copper sulfate aqueous, and Felling B is alkaline sodium potassium tartrate. Okay, sodium potassium tartrate, which is also called Rochelle salt. Aromatic aldehydes do not respond to Felling, but aromatic aldehydes do respond to toluene, and toluene occurs in what do you say, the alkaline medium, and this one is fucking wrong. Okay, don't mug up 4NH3. We have given the correct reaction before. Then limiting molar conductivity for some ions in water. So H plus is more than Ca2 plus is more than Mg2 plus is more than K plus is more than N plus Na plus. It forms that, it goes in the opposite order kind of the reactivity series. If you think about it, like, maybe you can remember it like that. I mean, that's how I would remember it. And then same thing you can go for this also, like you can go for the same logic in this and just mug these up. So yeah, you can mug this up with this order that I've given. OH is greater than SO4, 2 minus is greater than Br minus greater than Cl minus greater than CH3C double bond O minus. And then I'm skipping DNA fingerprinting. One thing that we have to remember is the yield in Sandmeyer reaction is found to be better than Getterman reaction. And you know that Getterman reaction is CuHCl. Okay, CuHCl is Getterman reaction, but Sandmeyer reaction is Cu2x2 salts, or even Cu2CN, or no, not Cu2, CuCN, CuCN. Okay, or I think it could be KCN also. I don't remember, but just check that in NCRT. Then you have, on oxidation of nitric acid, glucose as well as gluconic acid yield a dicarboxylic acid, which is citric acid, and that is only with strong oxidizing agent like nitric acid. With Br2 and water, it becomes only gluconic acid, which is replacing only one of the C, making it COOH only once. Okay. Then you have addition of sodium hydrogen sulfide, which is a very forgotten thing actually. Actually, the NCRT mechanism is very doubtful, but we'll be following that. So first, it somehow reacts and forms this, but it does a proton transfer. It doesn't somehow, my bad. It forms this using normal nucleophilic addition, and then you have proton transfer, which happens from here and here, and it forms a crystalline. Mark up this word, crystalline bisulfide addition product. And yeah, so basically position of the actually what we're supposed to learn from this is position. So yeah, the point of this is the equilibrium lies largely to the right hand side for most aldehydes and to the left for more ketones due to steric regions. And that sounds very counter. I mean, that kind of sounds intuitive, but it's still like we'll make it a thing. Okay, so here it says that although the 5f orbitals resemble the 4f orbitals in the angular part of the wave function, they're not as buried as 4f orbitals, and hence 5f orbitals can participate in bonding to a farther extent. So please mark this up, it's important. I also missed it while reading D block. So, and as you see, an LN2 plus CE2 plus configuration, for some goddamn reason, every element after this is in terms of F4, F2, F3 type, even though the original one was D1. Even though this is D1 and say 6 is 2, same way. Like, it's still like that for God knows what reason. Yeah, so basically after that we have preparation of aspirin. Aspirin is formed by acetylation of the OH group in salicylic acid. Okay, then oh yeah, this happens. I think this is one reaction that happens in the place of pyridine, so that the H plus doesn't go and break this once again. So that the remaining H plus it reacts with the pyridine because that is slightly basic. It's not very basic also. Then you have vanillin structure, which you have to mug up. Salicylaldehyde, though we can mug up because of Reamer-Tiemann reaction. Then cinnamaldehyde we can mug up because of the LiLH for reducing this double bond. Then alkoxide ion is a better proton acceptor, which suggests that alkoxide is a stronger basis, which is also PYQ. Alcohols also act as a Bronsted base, that too we know. Then brown ring test. Brown ring test, we need to know the full process, so I'll be telling. So basically, we take dilute ferrous sulfate solution and we add it to aqueous solution containing nitrate ion. Nitrate ion. Okay. Then we carefully add concentrated sulfuric acid on the side of the test tubes. A brown ring at the interface between the solution and the sulfuric acid. Okay, brown ring is somewhere here, and it indicates the presence of nitrate ion. And one thing that you have to know in this is that both NO is an NO plus state, okay, and Fe is also an Fe plus for some reason, because for no goddamn reason that we don't know, okay. These all reactions are very important, like this one. FeCl3 with NH4OH gives a brown precipitate of Fe2O3. This is also given in the math hound, I'm pretty sure. And ZnSO4 and NH4OH will give white precipitate of ZnOH twice, which is actually gelatinous white precipitate. Then you have Cu2 plus and 4NH3, which gives a deep blue precipitate of CuNH3 4, which we have also done in 10th grade. And AgCl, though we know because of so many places we've seen it. And AgCl in excess of NH3 gives AgNH3 twice, colorless. And this is the same thing that's used in tolerant test, I'm pretty sure. Okay. Permanganate, which means MnO4 minus, है ना? MnO4 minus should oxidize water, but in practice the reaction is extremely slow unless either Mg2 plus ions are present or the temperature is raised. Okay, then we have this very important reaction that has come in JME in 2026, and they've asked the molar mass of Fe2O3 in a very indirect manner, so we will be remembering this fully. FeCrO4 plus Na2CO3 with oxygen gives chromate. Okay, this sodium chromate is a yellow solution, it's not a precipitate, so please mug it up. Fe2O3 is your non-soluble part, okay, and CO2 is the gas that is released. And yep, that's all. And from here we have this one, increasing oxidizing power in VO2 plus Cr2O7 and MnO4, and we can check to what it is reduced, like because it's an oxidizing agent it will itself get reduced, and we have to check to what it is reduced. Okay, this one PYQ, and we've seen that it's 3NH3 as compared to seen previously. Addition of HBr to propene yields 2 bromopropane, but in presence of peroxide it yields 1 bromopropane. When reaction is carried out in the presence of peroxide, it follows the free radical mechanism, and 2 degree free radical is more stable than 1 degree free radical. Both assertion and reason are true, and reason is correct explanation of assertion. Then you have 8 azulene. As you guys can see, 8 azulene is not anti-aromatic; it is non-aromatic. And this also, this one, 10 azulene. This one, it has repulsion between the hydrogens, so it will also go out of play and it's non-aromatic. 12, however, is anti-aromatic, and then 14 is aromatic, 16 is anti-aromatic, and 18 is aromatic. Like that, we can remember. Then we have this very common name, which is, sadly, I think I've cropped out the name, so that's on me. Um, which of the following reagents would not be a good choice for reducing an aryl nitro compound to an amine? Just remember this, it would be LiAlH4 and in ether. Okay. One extra thing that you might need to know, that is iron, scrap, and HCl is the best. Is the best for reducing an aryl nitro compound to an amine. Yeah, so this titrant versus titrand, we'll be just putting it on the screen. You can pause the video and learn it. Okay. In intramolecular hydrogen bonding, the bond formed between a hydrogen atom and an electronegative atom within the same molecule. Okay, that's intramolecular. It also results in cyclization of molecules and prevents their association, which is pretty much makes sense. And this table is absolutely useless. I will not be remembering this. In the present form of the periodic table, the period number corresponds to the highest principal quantum number of the elements when the period elements having similar outer configurations belong to the same period. So assertion is true, but reason is false because it should be belonging to the same group, actually. Group, okay? Remember that. And nature of oxides, I will be pausing the video. I mean, you can easily know this. Like, this is just because of the trend, you can know it. And this one, you can remember as the percentage of oxygen increases, the acidicity of the element oxides, whatever, the acidicity will increase. And they are called acid anhydrides, as you guys know, and these are the corresponding acids, which are the oxy acids. Okay, then you have, okay, this one also, yeah, this one. Pause the video and just check all of these trends and make sure you got a decent idea about them. At least read through them. Next, you have ZNO. ZNO is yellow when hot and white when cold. Okay. Um, this one is fine, right? I think it's because of H2. H2 burns with the blue flame. Or is it H2? I'm not sure. Because the gas coming out of lime water burns with the blue flame. Yeah, check this once, but I'm pretty sure it's that. One atomic mass, okay, that's not something that we need. Okay, I'm going to be skipping this numerical. You can pause it and try it. And the last point is M and para nitrophenols exist as associated molecules. Just please remember this. Do not forget this is a statement based. It can be asked in boards anywhere. It can be asked.